Here we will solve a fourth power equation using the substitution method. When you're dealing with a higher power equation, let's try to get everything onto the same side, and since the fourth power is already on the right side, we will move all terms to the right side. Now we will take the 13x squared and the negative 36 and move them to the right. And when we move them, we will change the 13x squared to negative 13x squared and the negative 36 to positive 36. Now our equation will be a 0 on the left, and then x to the fourth minus 13x squared plus 36. You might notice that this pattern is similar to one we did in the past in the previous section. We have a fourth power term, and then a term in the middle that's half that power, or second power, and a constant. Anytime we have that formation with a large power, half of that power, and a constant, we can use the substitution method. And in the substitution method, we let our substituting letter, the u, become the half power. So I will begin by saying that u will be x squared. And if we square both sides of this equation, here's what we'll end up with. If we square the u, we will get u squared. And then if we square x squared, we will get x squared to the second power. But x squared to the second power is the same thing as saying x to the 2 times 2 power, which is x to the fourth power. Therefore, that x to the fourth power will change to u squared. We'll have minus 13x squared, but we said x squared was u, and then we add 36 and set this equal to 0. So effectively, we've replaced x to the fourth with u squared and replaced x squared with u. When you're doing the substitution method, what we want is to have a u squared and a u. Once you have this, you can factor this normally. Notice our number at the end is 36, and we can think of two numbers that multiply to make 36. We could try 36 and 1. We could try 18 and 2. We could try 12 and 3. Or we could try 9 and 4. However, our goal is to get 13, and so the only two numbers that add to make 13 are 9 and 4. 9 plus 4 would give us 13. That is the wrong sign, so our correct answers will be negative 9 and negative 4. Therefore, if we factor this, we will have u minus 9 and u minus 4. We will set this equal to 0, and now we've done a good bit of the factoring. However, we could go a little bit further. Previously, we said that u is the same as x squared. Let's try replacing that u with x squared once again, so now we'll have x in our equation. So in each of the u positions, we will place x squared instead. If we do so, we'll have 0 equals x squared minus 9 and x squared minus 4 for our second term. However, you might notice that these second power expressions are both perfect squares because we have a 9 and a 4 with a negative sign in the middle, and so we have two differences of squares. For that special formula, we will split our first parentheses, x squared minus 9, into two new ones, where we'll have x minus square root 9, x plus square root 9. We'll do the same thing to our second parentheses. We'll split that into two new ones, and inside we will put x minus square root 4, x plus square root 4. Therefore, we'll have 4 pieces to our equation. Set this equal to 0, and now we'll simplify all of these parentheses. X minus square root 9 becomes x minus 3, followed by x plus 3, followed by x minus square root of 4, which is x minus 2, and x plus 2. set all of these equal to 0, and you'll see we'll have 4 parentheses and we can expect to have 4 solutions. If we solve the first piece, x minus 3, we'll say x minus 3 equals 0, and therefore x equals 3. For our second piece, we'll say x plus 3 equals 0, giving us x equals negative 3. For our third piece, we'll say x minus 2 equals 0, giving us x equals 2. And for our final piece, we'll say x plus 2 equals 0, giving us x equals negative 2. So using our substitution technique allowed us to factor this into 2 parentheses, u minus 9 and u minus 4. However, when we replaced the u with x squared, we saw that we could factor further and get 4 solutions to this equation. Thank you for watching. We'll see you again soon.